Hey there, ladies and gentlemen. This is Mrs. Matheson. We're going to be covering Unit 8, Notes 2, on area of trapezoids, rhombi, and kites. So we're going to learn all those formulas today. And so our learning target is I can calculate the area of trapezoids, rhombi, and kites. Pretty straightforward. So let's talk about the area of a trapezoid. Area of a trapezoid we can look at two ways. It is half the product of the height and the sum of the bases. So our area is 1/2 the product, that means multiplication, of the height and the sum of the bases. So let's look at those. Remember, our height, just like in our triangles, is perpendicular to our base. And we have base 1 and base 2. It doesn't really matter which one you call base 1, base 2. Or we can think of it this way. Height times base 1 plus base 2. Instead of times 1/2, we can think of it as divide by 2. Both of those are going to get us the same solution. So let's go ahead and start with a basic one. Find the area of the steel used to make the razor blade shown. So razor blades, for X-Acto knives or box cutters are going to all be in this trapezoid form. So let's go with 1/2 times our height, which is 1, times the sum of our bases, 2.5 plus 3. So if we simplify, inside our parentheses here, we're going to get 5.5. So 1/2 times 1 times 5.5. And then 1 times 5.5 gives us 5.5. Half of 5.5, our area is 2.75 centimeters squared. Remember, area is always squared. So that one is easy plug and chug. We just put it in because we have all the information. Looking at our next one, it says one of Ella's trapezoid handbags is shown. Find the amount of material used to make the side shown. So we're only looking at the front here. But you'll notice that we are missing our height in this bag. So we need to find that height. I see that I'm given my diagonal here. And if I look, I actually have a triangle, a right triangle to be more specific. So I have the hypotenuse and I need to find one of the legs. I need the other leg. Well, let's see. If I drop this down, we know that this distance is 28. So this distance is also 28. So that means I can take 58 minus my 28 and I get 30. Now that 30 is for this part and for this part. So half of half, that gives this as 15. So I can say 15 squared plus h squared equals 30 squared. Now why I'm not using 30, 60, 90 rules? Because it kind of looks like that triangle, but we don't know for sure because they don't tell us. But we do know that it is a right triangle, and there we can use our Pythagorean theorem. All right, let's round this to 1 decimal place. Go ahead and finish it. Find me that height. All right, so what's that height? Well, that height is going to be 26.0. All right, so let's look at it this way. Height times base 1 plus base 2, and I'm always going to write my base 1 as the shorter leg, no matter if it's the shorter base, no matter if it's the height or the top or the bottom. And now let's do divide by 2. Go ahead and do the calculations. 28 plus 58 times it by 26, divide it by 2. I'm not going to do these calculations out for you. They're not that hard. We end up with 1,118. Don't forget a label. Remember, labels are really important. They're easy. Centimeters squared. Okay. 3 says, Kevin designed a deck shaped like a trapezoid shown below. Find the area of the deck. Okay, again, we can drop down. We need to find our height. And our height, actually, we already have. Because if we see we have 4 feet here, we can just bring that right over here. And we have a height of 4. The thing that we're missing is our base 1. Our base 1. So thinking about that, I'm going to again look at my right triangle, which is over here. I have a leg of 4, a hypotenuse of 5. Oh, this is familiar. This is familiar. A leg of 4, a hypotenuse of 5. What's my other leg? Yeah, it's Pythagorean triple. 3, 4, 5. So that means that this portion that we're talking about right here is 3. So that makes this 6. So that means my base 1 is 6. So we have a height of 4, base 1 plus, and remember now we're talking about the whole base, divide by 2. All right, so looking at that, that is going to show me very simple calculations. Again, go ahead and do those simple calculations for us. Adding them together, times it by 4, dividing by 2, and we get, yes, a 30 feet squared for the deck. So here's a real world example where you might need to find your area of your deck, because I bet some of you guys are going to have houses with decks on them. All right, last one here on the front side with trapezoids. Emily designed silver earrings, and they're shown that are shaped like isosceles trapezoids. What is the area of each earring? This one is going to be similar to our problem 2 with Ella's trapezoid shaped handbag. We need to find our height. And we are given base 1, base 2. So if we bring this down here, we know this part's 2. 4 minus 2, 2 goes for that. And for that, remember it's getting split. So this is 1. So we're going to do 1 squared plus our height squared equals our hypotenuse squared. Go ahead and find that height. Let's round it to 1 decimal place. Oops. I gave you a little bit of answer there. So when I put height here, 2 plus 4, divide by 2. I want you to go ahead and finish this problem, find our solution, and put that in. It'll probably be on your Schoology quiz. Okay, I'm going to give you the area formulas for kite and rhombus. Kite and rhombus have the same formula because they have the same idea. They both have a diagonal 1 and a diagonal 2. Okay, in a rhombus, those diagonals are not going to be the same, just like in a kite. Your diagonal 1 and your diagonal 2 are not going to be the same. Okay, so let's just say we have diagonal 1, which is our up and down, and then our diagonal 2, let's just say, can be this. Again, it's just like the bases. It doesn't matter which order you do them in. So our area formula is 1/2 the product of the diagonals. So product again means multiplication. We can also look at it as multiplying the diagonals and dividing by 2. So you guys can go ahead and do 5 and 6 for sure. I want you to try 7, and we'll look at 8 in class together. We'll see you guys then.